Hi, myself Y Nitish Kumar from ITA. My topic is nodal analysis of electrical circuits. In electric circuits analysis, nodal analysis, node voltage analysis, or the branch current method is a method of determining the voltage potential difference between nodes points where elements or branches connect. In an electrical circuit, in terms of the branch currents, in analyzing a circuit using Kirchhoff's current laws, one can either do nodal analysis using Kirchhoff's current law or mesh analysis using Kirchhoff's voltage law. Nodal analysis writes an equation at each electrical node, requiring that the branch currents incident at a node must sum to equal to zero. The branch currents are written in terms of the circuit node voltages. As a consequence, each branch constitutive relation must give current as a function of voltage. An admittance representation, for instance, for a resistor, I branch equals to V branch into G, where G equals to 1 by R is the admittance of the resistor. Note are connected wire segments in the circuit. These are the nodes of nodal analysis. Select one node as the ground difference. The charge does not affect the element voltages, but it does affect the nodal voltages and is just a matter of convention. Choosing the node with the most connections can simplify the analysis. For a circuit of n nodes, the number of nodal analysis equations is n minus 1. Assign a variable for each node whose voltage is unknown. If the voltage is already known, it is not necessary to assign a variable. For each unknown voltage, form an equation based on Kirchhoff's current law. That is, add together all currents leaving from the node and mark the sum equals to zero. The current between two nodes is equal to the voltage of the node where the current exists minus the voltage of the node where the current enters the nodes, both divided by the resistance between the two nodes. If there are voltage sources between two unknown voltages, join the two nodes as a super node. The currents of the two nodes are combined in a single equation, and a new equation for the voltages is formed. Solve the system of simultaneous equations for each unknown voltage. Super nodes. In this circuit, we initially have two unknown voltages V1 and V2. The voltage at V3 is already known to be VB because the other terminal of the voltage source is at ground potential. The current going through voltage source VA cannot be directly calculated. Therefore, we cannot write the current equations for either V1 or V2. However, we know that the same current leaving node V2 must enter node V1. Even though the nodes cannot be individually solved, we know that the combined current of these two nodes is zero. This combining of the two nodes is called the supernode technique and it requires one additional equation. Analyzing electrical circuits is vital to ensuring modern technology works as expected. Most modern electronics go through some sort of immersion and evaluation process to ensure designs work as intended and to provide a set of reference calculations for comparison within circuit tests. Spice simulations are the workhouse for circuit design and analysis, and today's commercial solutions provide many built-in simulations. Among the simulations found in Spice simulators, nodal analysis is a fundamental technique used to examine voltage and current distribution in a circuit. This technique effectively combines both of Kirchhoff laws and Ohm's law into a single matrix equation. Keep reading to learn more about what nodal analysis is and how it's used in circuit design and analysis. Nodal analysis is a mathematical method for calculating the distribution of voltages between nodes in a circuit. Also referred to as the node voltage method, the strategy uses Ohm's law, Kirchhoff's voltage law, and Kirchhoff's current law to define an equation relating the voltage measured between each circuit node and some reference, usually ground. The voltage drops measured between neighboring nodes are taken as the variables in a set of linear equations, and the system can be solved using a standard algorithm, example Gauss-Jordan elimination. One key to doing nodal analysis successfully is to properly define reference nodes, also called datum nodes. In nodal analysis, a reference node is the point that is used for comparison when measuring voltages because the voltage is only defined between 2 points in space. Imagine you were using voltmeter on your circuit diagram. The reference node would be the point where the negative lead was connected, and the positive lead would connect to any other node. This is why voltage measurement probes in SPICE simulations are normally shown as a single probe. The measured voltage is taken with respect to a reference node in the circuit. In SPICE simulations, the reference node is normally taken as ground. If there are two grounds, the reference node is taken as the nearest connected ground potential. In nodal analysis, any node can be taken as a reference point. This gives you an advantage in that you can define the potential difference between two different ground points, such as you might find in galvanically isolated PCB with two different ground planes. How does nodal analysis work on nonlinear circuits? Because the current and voltage is a nonlinear component, is a nonlinear function, The matrix equation developed in nodal analysis will have terms that are functions of the voltages at different nodes. In this general equation formulation, applying nodal analysis to nonlinear circuit requires solving a transcendental matrix equation for multiple unknowns. This can be a very difficult numerical problem to solve depending on the form of the derived matrix. Therefore, in order to examine nonlinear circuits using nodal analysis, the current versus voltage relationship measured between adjacent nodes in the circuit needs to be approximated around some operating point. The typical method to do this is to use one of the following general approximation techniques for a nonlinear time invariant system. Taylor series for a system of n components define two n new variables that are shifted away from the intended operating point with a linear transformation. Now expand the current voltage function for each nonlinear component as a Taylor series in terms of these new variables. Macron series. Expand the current voltage function for each nonlinear component directly around the operating point without defining new variables as a Maclaurin series. By keeping only the first order items, you know how to have a linearized circuit that includes nonlinear components. The results from this procedure are only valid within a small deviation from the operating point, depending on the impedance function for each nonlinear component in a system. Circuit simulators that use iterative solution techniques will apply these approximations for you and can solve operating point matrix equations in nodal analysis or for nonlinear circuits. Vital node voltage and nodal voltage analysis requires a strong understanding of current source in your electronic circuit, but when tasked with unknown node voltages or independent voltage source, your nodal equation can get difficult. Looking at principal nodes for your current source and branch current references can encourage a better understanding of nodal voltage, but generally, for electric circuit performance, circuit analysis through SPICE simulation will unlock all types of circuit variables from transient analysis to parallel circuits to various matrices and beyond. Use your node equations wisely in your next electrical circuit design. If you are still unclear as to what nodal analysis is, you can use an industry standard SPICE simulation to calculate voltage and current throughout your circuits. Once you have got your results and you are ready to create your physical design, use the best set of PCB design and analysis software to capture your schematics as a blank circuit board. Allegro PCB editor from Cadence gives you the layout and routing features you need to create your circuit boards and prepare them for production. You can then use nodal analysis users results as a comparison for electrical tests. TV. What do you need to prepare before using this method? Keep in mind that we will get n-1 equations where n is the number of nodes including the reference node. Using this circuit analysis method means we will focus on node voltages in the circuit. Nodal analysis circuit properties. Nodal analysis circuit uses the Kirchhoff's current law. For the n nodes, there will be n-1 independent nodal voltage equations. Solving all the equations will grant us the node voltages values. The number of nodes is equal to the number of the nodal voltage equation we can get. Thank you. This is my presentation.
Okay, no?